So my name is Anshu Manik, and I manage the Wolfram Technical Consulting team. What I'm going to present today, I have titled it as Interesting Projects and Concepts. The idea is that I would be presenting some of the concepts as well, and then there is a running theme that I wanted to address in today's talk. Generally, there is an ongoing discussion or debate about what type of tool are actually good to have, whether it should be all pre-built point-and-click types of tools, or should we have everything totally under control of the end user. He should be able to program his way up and be able to do it exactly the way that he wants. Obviously, there are very, very strong pros and cons to both sides. Then what would be the right type of solution? That becomes a debatable topic, right? But then I'm trying to present that it need not be that debatable as such, and Wolfram language does help us out a lot when it comes to that. And this theme actually covers most of the areas that many of us would be working in. So Wolfram language, when you start Wolfram language, let's say in Mathematica, you see a blank screen. So it doesn't give you point and click ability. But then it allows us to very quickly build things up and then be able to get our path ahead. So I'm going to go through that theme as we go through different topics in the presentation, different projects and concepts. But before I get there, let me very briefly describe, as a matter of courtesy and completeness, that the Wolfram Consulting team actually works with any and every client who may be working on their project using Wolfram language or Wolfram technologies in general. And we have different types of offering to be able to help our clients. So that could be in the form of project support, where we take the data and specifications, and then we do design, development, deployment, or we work as an extension of their team under what we call as development support or business support, where some of our consulting team members become sort of a longer term part of our client's team to be able to do variety of different things. For advanced training, when we keep specific project in mind and provide training customized for completing that particular type of project, and application support for supporting the applications which have been developed using Wolfram technologies in general. Now, I think most of us would agree that Wolfram language is just so broad-based that pretty much all the sectors of the economy do use our tools at different levels. And that's also represented in the projects that we have been doing for our clients. As you can see here, engineering and technology, that does form almost a quarter of projects, but then very closely behind is finance and banking sector, government sector, manufacturing, education, and so on. So you can see that we're involved with pretty much all the different sectors of the economy, which is really, really satisfying because we're able to contribute in all those fields. Now, coming back to today's talk and the theme that I was talking about. So let's start with ETL processes. So this is simple extract, transform, and load process that any data science project would need, pretty much any manufacturing place will need, and so on. So why is it that I'm presenting that here? That's very basic. But the reason I'm presenting that here is that ETL processes also tend to be quite variegated, depending on the data that one has to deal with, the types of transformations that are required, and so on. And even high-level tools may be able to address many of them. But what if we could build our own tool rather quickly and be able to get just the types of functionality that we need, just the features that suit our workflow, and then be able to make a lot of progress beyond that? So we start with almost a scratch, like a blank slate, but we get to point and click type of environment for all repeatable types of tasks. So that will be one aspect of the theme. Then the second aspect is that for all those instances where the tasks are actually repeatable, why don't we just build these point and click tools very, very rapidly and be able to use them and save enormous amount of time, while giving us the opportunity to extend that work using a programming environment like Wolfram language to any degree that we may need. And I'm going to present examples to bolster that argument. So let me first get started with the small prototype that we developed to sort of demonstrate this idea. Let me pull up the tool here, just a second. Okay, so this is something that was developed rather quickly. Let me go on to VPN because it might need that to connect to the database. But in the meanwhile, let me get started. So this is, let's say I start with extract. So the extract, transform, load, and visualization, these different modules. So here, as you can see, we are providing some very robust features like source. So I can go ahead and choose a particular source. Let me go ahead and choose this entire folder. Choose. And what it is going to do is actually go into that particular folder, extract all the data tables that are there, and it is presenting it to me. Now I can work with any of them. And first thing to emphasize is the variety that it can deal with. So for example, database tables or CSV files or other types of database tables, XLS files and log files and JSON, TSV, those are all very easily supportable because we have this very powerful import-export functionality. On top of that, we also have lower-level stream readers. So for this, let me just go ahead and get started with a simple one. So I clicked on one of the CSV files. This is asking for some standard questions. I'm going to import. Now, if I want to see if the data did get imported properly, it looks like that I'm seeing a snippet of the code. So this is just showing first 20 lines, the first 19 rows. If I wanted, I could go ahead and see actually 20th to 50th, just to get an idea. And I can see the types of columns that are there, the types of data that are there, and the missing values that are there, which are highlighted. We can see lots of missing values here. So it gives me a very quick view. Nothing great about it, but it is all in one place. Now I'm going to do something more variegated than that. So let's look at data set summary itself. So it is now going to give me a summary of the entire data set itself. And I can continue on to get the summary of each of the columns. So generally, when we get the data, we can have it in a spreadsheet, which is all good. But at the same time, at the same time, we would need to know more, get certain statistics automatically from there. So see, in this case, it is now telling me what's the format that each of the columns came in, how it was interpreted. Some of the columns were automatically transformed. For example, date came in as a string, got transformed to date object. So I can work directly with it. And then different, let's see, I think it's cutting off a little bit. Yeah, this should be better. So here I can see that there are certain columns where there are a lot of missing values. This will be a matter of concern. There are others where there are just few missing values. I'm going to be fine with those. I get, so this is single valued columns. That's another concern. If an entire column is going to have exact same value, it does not help in modeling, right? So we have to be aware of that. And this represents the similar idea in terms of pie chart. If I go to column summary, then it would go to each of the specific columns. If you see, these are the columns that were there. And now I can look at the specifics of each of the columns to the extent that I need. So now this is the idea that, this tool was developed rather rapidly, but it is doing just the types of things that my team actually needed. If I want, I can go ahead and have histogram. Maybe I should have some other column here, like size of home. Let's see if it gives me a histogram. it gives me a histogram. So I can get an idea of the distribution that may be there. So this is just the extract part. And a lot of features are there for transform. So first is typecasting. If it came in as a string, do you want to keep it as a string or convert it to an integer or real or whatever? And I have the ability to change any of them. In the interest of time, I'll not be able to go through all of this. I wish there was more time. But if I wanted to, I can. So I can convert, let's say, real to integer. Let's say if it's a year, then why should it be real? It should actually be an integer. So I can change that. And then I have the ability to export the modified table out. That table would become available here. And if I move it to source from here, add to source, then it becomes available here. And then I can work with it. Beyond that, I can also take different tables and be able to join them. So joining using key values, either inner join or just plain join, whatever the need may be, or group the data. For example, I can group the data, let's say, based on project city or, yeah, maybe year home built. And then what is it that I want to target there? So let's say size of the home, yeah. Select action. What do you want to do? Let's say we want to do total of the size of the home. So now this would give me an idea of the total size of homes constructed in these years, right? So this all happens with point and click. Similarly, I could do filter if I wanted to. I'll skip that in the interest of time. Now, given all of these features, I can go ahead and load this. I can actually insert all of this into my database. So it came in as flat files, but I can insert them into databases. So I have standard tables available, but I can go ahead and create a new table right from here. So let's say new test table. And I'm going to generate the SQL command for that here. If I want, I can edit it or go ahead and execute it. I'm not going to execute just to save time. Let's do it. Okay. And then that table has become available here. Yeah, new test table. And then I can go ahead and if I wanted to push the entire data that I just worked with into that table. So similarly, then I can query from the that particular database. I can filter, I can group, and so on. Then again, there is visualization available. So now you get the idea. All of this was developed very, very rapidly. And this actually addresses just the types of things that a particular user or a particular company may be wanting to do. So he doesn't have to program for this. But then after all of this is done and data is available, what do? You do different types of data science projects, or you do different types of analyses and so on. So for that, then Wolfram language provides another framework where we can do that in a very, very elaborate way. So let me go to a sample project that I wanted to show. Yeah. So this is a data set that we got from NSCG. Here, if you see, nothing is point and click. It's going to be programmed, and there is strong reason behind why this is very advantageous. So the data set is very large. I mean, not very large, 150,000 rows. That's good number of records for the types of analysis we wanted to do. More would have been better for sure. But generally in data science projects, as you know, that just importing and cleaning the data takes so much time. Particularly, this was survey data, which poses its own challenges. So there are so many different tools that are available to do all of that very quickly. Do the cleaning, then draw down the number of features. I think there were 120 different features to something more manageable, something which is realistic for analysis. Do exploratory analysis, and then be able to run regression models. We even use functionality from graph and subgraph to be able to pare the data down. Then, of course, there's standard functions like select and delete cases and whatnot. So now here, if you see, we started with 120 features. We actually pared it down to 17, but different things that we had to do was very interesting. So individual identifiers were there in the data. That doesn't help with analysis. Remove them. Non-discriminative features means which don't have any variability, then it's not going to help with the model. It's only going to create ambiguity, if anything. So we removed, many of them. Highly correlated variables will have to be removed. Otherwise, there'll be another, confounding situation that is created. So we used all of that, and that could be done rather quickly. So here is a sample code. No, not this one. Where is that code? I think it's down below, so I'll go through that later on. And then we ran regression to see what that data actually looks like, what are the correlations. And just, okay. So here we see something which may seem very plain and bland to begin with, but it becomes very interesting very quickly. Green represents no correlation, which is really good because that means data has a lot of intelligence in it. But then we can see certain specific areas which deviate from that trend, like this one. This shows high level of correlation. So if you look at it more carefully, this block actually represents different types of satisfaction variables, how satisfied people are with their job. There are different types of satisfaction. So if you see there's stronger correlation to some of the satisfaction values, with this one is just pure job satisfaction. But beyond that, if I look at the ones which are not correlated within this block, so let's see this one. If I go all the way to the left, this is satisfaction based on location. And if I go down below here, satisfaction based on benefits, satisfied by the benefits provided by the company. And we see that they are not correlated. This is interesting because although generally satisfaction variables tend to be correlated, but this one is not. So we should understand, where to draw the line, right? And this is a good example. One will be willing to sacrifice location for better benefits and vice versa. Whereas other things are concerned, they would strongly correlate. If they don't like this, they don't like that either, right? So there are actually many different insights like this that can be drawn just from this correlation matrix, which again comes as a standard tool available. So if I go forward, similarly, we had several discussions based on these. What I really like is that most of our discussions were about the data, the intelligence in it, rather than how to implement that, how to generate the views, or how to do the analysis. No, those were very simple for us. I'm not going to go through this detail, but univariate analysis was very simple for us to do. We had all kinds of tools in our hand, like density histogram gives me an idea relating, let's say, salary to age. We ran independent tests. This, for example, says salary and age are strongly dependent given all these different tests and so on. So these tools helped me get there very quickly. Once we had gone through this entire process, then running the regression model itself, after cleaning then those analyses, then running the model was very easy because linear model fit allows me to just pass the data straight on. These are the features we had drawn down to. Most of the variables in this case were actually nominal variables. They had weights and we can take care of them directly. But given that these are nominal variables, we know that interaction effects cannot be understood from here, right? Because those require numerical variables. Anyway, so those were taken care of, and we see that the R-square value we got from the regression model was 0.49, which is not too bad because we're working with salary data related to age, gender, education, location, and whatnot. So, of course, as you can understand, I'm skipping through a lot of details because the itself would have taken an hour if I went into details. But then if you see here, finally, what we are getting is really nice. These are all clustered around the unity line. This is between predicted and actual. Yes, it is under predicting a little bit, but majority of the cases actually fall right around the unity line, which is encouraging. So this model is not bad, despite seeing our score of 0.49 as such. And I'm not surprised because for this kind of subjective database with so many nominal variables coming from survey data, this is to be expected. If I got 70%, I would have doubted the model. So the point here is we could go through all of that rather quickly, but then we want to also compare that to other types of models. I showed regression. We zoomed down to regression because they were giving the best results. But then we went through other models as well, and rather quickly, because we have neural network framework, which allows us to do the neural net training and be able to see how well they're fitting. And these are the standard deviations. So lower the standard deviation, better the model. Here we see that decision trees perform so, best was gradient boosted trees, and so on. But linear regression, in fact, in this case, without some of the transformations we did to the data, was not doing as well. We made those transformations, and then we could improve the R-square to 0.49. So this is an entire journey through a data science project, starting from ETL all the way to running the models and comparing the models and so on. So this is very interesting, right? Conclusions we draw from there. Some of the things were very interesting. I'm not going to go through that just to save time. I do have some other very interesting things also to show. But anyway, the main point that I wanted to make, I think I did address that at least. Let's go to the third one. This is from one of the companies that we are working with. It's a startup from Australia called Fossilitex. They have come up with really nice offering. They're going to provide advanced flow analytics. They're integrating machine learning, and they're going to allow for integration of different data sources and different services. They're going to add up their services on top of that. The reason why am I talking about Fossilitex here? They're using Wolfram language as a platform. And here's the bigger picture, and I really like it. If you see, this shows the digitization journey for different sectors. And here, if you see, tourism seems to be far ahead of other different sectors in the economy, which is very interesting. This is driven by demand from common people, because they're just going to say, hey, make it easy, otherwise I'm not going to come. So tourism industry has responded to that, and they're far ahead in the curve. There are others who are doing well, like media and telecom, but then we see other ones who are trying to just catch up, like retail banking. It has gone pretty far, but then retail distribution is a little bit behind. High tech is still trying to catch up, even though it is high tech. But then other picture also, unfolds here. Utilities lagging behind, chemicals and agriculture lagging behind. Look at oil and gas. This is the bigger picture. This company, Fossilitex, is trying to address that at a high level and then be able to offer specific solutions. So types of solutions that they're offering, let me quickly go through that. So these are the types of analyses that are already available. Decline analysis, this is for oil and gas industry. So decline in production of oil and gas. Wellbore modeling or gas diagnostics or purity and hydrates. And they're working on Monte Carlo simulations, water analytics, and so on. What all of these tools put together is going to do is allow these oil and gas companies to identify the production problems, identify the bypass hydrocarbon, which means you don't just let them be there. Do the wellbore losses so that you can minimize them. Identify poor fracture performances and be able to correct them. Then what the remedy will be, which will lead to production enhancement and so on. And then also be able to predict into future, with confidence what can be done, to improve those scenarios. Basically, they are allowing for integrating different data sources that are available and bringing that to one platform, which is being powered by Wolfram language, made through a cloud application, and then end users will be able to interact with them with various tools like these, which would help them use machine learning to improve their prediction power, for example, play with different scenarios and come up with remedial measures, run different simulations, be able to see what the decline models are looking like, what's the oil and gas in place that's available, and so on. So it's very, very interesting. Okay, now the last part. This is very distinct project. I want to breeze through this, but I had talked about sort of an additional layer that can be put onto learning management system for different universities and schools. So we are rehauling that, and this is work in progress. I'm not showing the actual platform itself, but what we are doing is we are not developing another LMS. I think, this is going to be an addition to LMS, but more than that, this is going to be a platform. It's a framework. What it does is that it has a core. Let me get the notebook. Yeah, so it has a core where students will be able to log in, admins and faculty will be able to log in. Faculty will be able to see their previous, recent history, see the courses that they're active in, search through them, go to any of the specific courses, be able to see the homeworks and quizzes that they have issued, the ones from the past, the ones that are current, and so on. Be able to look at the specific questions or create new homeworks and assignments, be able to put in metadata for those homeworks and assignments, being able to identify the specific questions, add them, remove them, and whatnot. Then be able to preview the questions and the various metadata associated with them. Then be able to see how the student will see it. They can emulate a particular student. Then this is a student's view. So a student will be able to see all the homeworks in his particular courses that he is registered in, and this can be connected to the university authentication system, and so on. So these are like the core features that you would expect, right? So what we have done is we have developed this framework. This core is already ready. Now different institutions can take this core and ask us to customize it ad infinitum, allow the students to practice using automated problem generator, being able to try as many problems as they want, and being able to auto-grade that on the spot, be able to see their performance, see practice performance, see their exam performance, and so on, and be able to go to specific questions and be able to actually look at what they did right and what they did wrong. It's really nice because there are core features, and now every institution has that flexibility to adapt it to their needs, their methodologies, and have their, the distinct features that they bring to the table for the students built into the system rather than being required to adapt to existing systems. So I really feel excited about it. And now there are actually several entities talking with us to actually go through this process with us, customizing it for them. So that was the last one that I wanted to present for today. Beyond this, of course, we are available for any type of discussions that you may want to have in this area. But I'm going to repeat the theme. The theme is it presents an opportunity, a platform, which allows us to rapidly develop, point and click types of tools for repeated kinds of calculations and processes, and also allow for all kinds of customized, programmable extensions or simulations and so on. Okay, so I'll stop here. We have just a couple of minutes, I guess. Any questions from anyone? Okay, so what do you use to get this notebook as a GUI? Oh, so there are actually specific control objects which are available for buttons and sliders and panes and whatnot. So if you just look for the GUI guide page, it'll show you those and you can use those. How long it takes a data science report project? Of course, it'll depend on the data, I'm sure you know, but it can be a very rapid progress. So what I want to say is that if you have the data, then majority of your time is going to be spent in doing actual data science rather than working on the tools. For example, the example that the data science project I showed, that would take, for somebody who practices data science, it'll take them only about a week or so to complete it from scratch to finish. So that's very, very fast. Given that data set was large, so much processing was required, right? Read CSV or XLS files provided by client and does an analysis. Well, that's one aspect of it. A lot more than that also can be done. again, then data, we all, Wolfram language has the symbolic capabilities, which educators then can use in many different ways. And in fact, we're working on some of those to extend the types of questions that can be presented to the students. For example, we can integrate step-by-step solutions, which is terrific, and so on. Okay. Yes, Daniel, yeah. If we have worked together previously in the past, we can do actually more together if you would like. This particular project was interesting for us. We have done so many others with customers, but then we wanted to see in a very, very concentrated way how quickly we can do. And this was a very, very fast process. Of course, we are talking about those who do data science, day in and day out. If there's a learning curve involved from data science perspective, obviously that's a different thing altogether. Okay, good. So I think I've reached the time limit. We'll stop here. I really appreciate your time. Thank you for being here. Bye.